All right, so as Calvin just introduced, my name is Matt. Um, this is deploying your services to AWS without leaving the comfort of your desktop because the AWS console is terrible and I don't like to use it. Just a little bit about me, some background. I graduated from Purdue about 3 years ago. I work at 6 Feet Up as a sysadmin, DevOps, carpenter, mover, you name it, I'm kind of there. Like following open source, contributing where I can, usually not a whole lot, and kind of just like to tinker with a lot of stuff. And I have a picture of my dog up there. That's George. He's a 70-pound lap dog. So the problem that we have been running into is that basically managing your servers by hand kind of sucks. They're always handcrafted, they're hard to replicate. And then just working with AWS in general is kind of hard because there's all kinds of moving pieces. The API is changing. You need to have this to work with this, to work with this, and it's just a long chain. It gets really confusing really fast. And there's not really any tool that I found that does all of it at once, which is kind of what I was running into a lot of. So we use a lot of Saltstack at 6 Feet Up. We use it mainly for configuration management and automating tasks. So we set up a server, install Salt, and then Salt handles everything else for us. Code deployments, inventory, basically anything that we can automate is usually ran through Salt. Some of the problems with this is that pushing out code or pushing out infrastructure through Salt is kind of painful. It's very much a push, it's not stateful. So if you set up things in AWS through Salt and try to run it again, sometimes it will try to overwrite them, and then you get failures, and then it's a cascading failure because they run one after another. So that was not a fun experience. Another one is, you can run Salt masterless, so you don't need a centralized control point, but it's a lot easier if you do, because then you get the full benefit of all these automation tasks that you may have seen in one of Calvin's talks in the past. I'm not going to go too far into that today. Another tool that some of you are probably familiar with is Terraform, which is fantastic as an infrastructure piece. It will deploy things really easily. It's cloud agnostic, so a lot of people use it for AWS, but it can be used for Google Cloud or some of the others. But it's not great for the server config. It'll put all your infrastructure out there, but then your only real configuration option is a user data script when you first set up your server, which can go well, can go wrong, but then you can't update it later. So obviously my solution is to put these together, and hopefully it works well. So my plan when I was putting this together is to use Terraform to push out all of our infrastructure. So we're going to set up the VPC, the network stack. We're going to set up the instances. In this case, for the demo that I have today, we're not going to do the RDS and S3. I just didn't need it, but it's fairly trivial to add in. And then once that's set up, we're going to use Salt to set up user accounts and packages and do code releases and all of those. So I'm going to start by going through Terraform, since if you don't have any infrastructure, you can't really do any server configuration without servers. So this is just a general what the Terraform file format looks like. The rest of this is going to be kind of code heavy, but I hopefully broke it down enough that it'll be easy to follow. But so basically you define your resource, which in this top example is a VPC, and then you give it a name. So later, if we need to reference this, we can say, I want the AWS VPC that's called name, and I want this attribute for it. So you can reference other AWS functions in different states, which makes things significantly easier going forward. This is the file structure that I like to use for simple things like this. You can put all of this in one big file. You don't have to split this up. But in my experience, that gets really hard to read. So to me, it just makes more sense to split things up like this, make them, all your network stuff is here, all your server stuff is here. It's just easier for me to follow at the very least. So we're going to go over the variables file real quick. Just my goal with using a variables file is that if I'm ever updating something in my Terraform, this is the only file I want to have to touch. I don't want to have to go rewrite modules. I don't want to have to push out new servers, new code, rewrite stuff. I just want to update it here and say, oh, I want 2 of this server instead of 1, so I'll just add a new one and push it out. Following that, we got the network, which is missing a picture. That's awesome. So basically, the network handles your routing tables and your VPC, your NAT, anything required for your network to function.
You're going to need to mime the picture.
I don't think I can mime a code block. I'm sorry, Calvin. You're going to have to get over that. Oh, there's the picture. My slides lied to me. Yeah, so you can see we're creating a security group, and this is kind of important because when you're setting up your security groups, at least one of the security groups attached to your servers needs to have this egress. And if you don't have this, things are going to break, and you're not going to understand why. And you're going to see a nice example of that coming up right next, because this drove me insane for a long time. In this case, I want to use EC2 tags as the control points for my salt states. So some of AWS's metadata is available to the servers themselves locally. For whatever reason, AWS tags are not. So there's an external Python script that we can run through Salt that will pull these down. So we set up a custom IAM role that is attached to all of our servers that allows it to read those tags. The reason this drove me crazy is because it kept failing and I couldn't figure out why. It just gave me errors and not returning and every error under the sun, really. And the problem that I eventually found is that I hadn't attached that egress gateway, so this wasn't able to actually hit Amazon's API. So obviously, that wasn't working. And obviously, when you don't have an egress gateway, no traffic can go out. So you couldn't install packages, you couldn't run updates, you couldn't do basically anything. So if you want something super isolated from the internet, you cannot not put an egress on it. Otherwise, you probably want that. So now that we have the network set up, we can run through and set up our servers. In this case, we're going to make a Salt master. So on the left, you just see we're going to do the AWS instance. I'm naming it Salt Master up here. If I can find my mouse. There it is. So we're naming it Salt Master up here. You can see that we're referencing some of our variables from before. So here's our EC2 tags role. Here's the region, subnet. So we can reference things from this module over in this module. And then we're just passing in a simple bash script as user data that's going to install the Salt Master and check out the Git repo that has our salt states in it. So the second part, obviously you have a Salt Master, you need something for them to control. And I realize that's a little small for those of you in the back, but this is online so you can all look at it in your own time. But again, all the variables that we used in that variables file right at the beginning are referenced here. But this roles tag down here near the bottom, so that's where this is what Salt is going to be picking up. So whatever you define in this roles tag, that's what Salt's going to use to determine what kind of server this is supposed to be, whether it's supposed to be a VPN server or a WordPress site or a static site or anything under the sun that you define a role for and write a salt state for will work here. So now that we have all of our servers set up, we're going to move over to the Salt stuff. And Salt is really simple once it clicks. But until that point, it's a little weird. So in this case, it's just really simple. So a pillar is basically nothing more than a variable store. You put data there, you can reference it later, that's it. The states are what is actually doing work. So I have a static site state that's going to pull values from the static pillar and then set up a website for me. The top file is what controls what goes where. And a map file is just basically a lookup dictionary for different files, different OSs, different locations, such stuff like that. So this is just an example of a pillar. So you can see that I actually have two defined here. I have a clone and I have a static. In this demo that I'm going to do, I'm only going to run the static because Plone just frankly takes too long to build for this, and no one wants to watch me stand up here awkwardly for 20 minutes waiting for that. I don't care what you think. We can rotate through the room. How's that? Everyone takes a turn. So as you can see, this is just a really simple data store. You can easily expand this out. So if you're building your site and you want Let's Encrypt certs, you can just have another field there that says Let's Encrypt true or false. So if it's true, then you run and build an SSL cert. If not, whatever. If you want to include load balancing, either through an ELB or an ALB or a local HA proxy instance, you can use pillars to determine what user accounts go where and who has what permissions. And basically, this can be expanded as far or as little as you want. Most of them that we write are significantly longer than this, but for this example, it's just nice and simple. Just an example of a map file. So this is what I mean when you say you can change packages and locations based on operating system. So if you work in an environment where you have multiple operating systems, you may notice that different OSs name their packages differently. You can see that Red Hat and Debian have free type named differently, which is kind of a problem if you're just writing bash scripts. It gets really complicated. So in this case, it's just easy. So you define all of these in a big dictionary map file, and then you can reference them in your code down below. So you can have, we're installing free type here. It's going to go look at this, and it's going to look up based on what operating system it is and pull the right values. Here's an actual state, and this is the one that I'm going to run shortly. Again, a little bit small for you in the back, sorry. Had to fit it on the screen somehow. So basically, we're including the Nginx block here. So we're going to call an Nginx state that is going to basically just install Nginx and put a very bare minimum config in place. So then we're going to include a static.conf with just an engineering or a static Nginx block. So it'll tell it where to find the files that we want to run. It's going to check out the pillar repo, which we have from what we defined in the pillar earlier. It's going to check that out and put it in a location and set the file permissions so that the web server is able to read it. And now we are going to hope that everything works. Because last time I did this, the demo gods smited me before I even walked into the room. So here is our repo that is up on GitHub, and anybody can go look at this or experiment with it as you want. So we're going to jump into Terraform. We're going to do a Terraform apply. And we're going to break because I don't have internet. Okay, stand by while I fix this. I tempted the demo gods again. So now we're going to run an apply. So when you run a Terraform apply, it spits out all of this, which is basically, here's all of the stuff you just told me to do. Is this what you want? And it asks you yes or no. So in this case, we want to do yes. And now we wait. And judging by my testing earlier, we have about 4 minutes, and then I'll have a website that we can show. So if anybody has questions, now would be a great time. Otherwise, it's going to be real awkward.
So you've gone from there's nothing existing, no VPC, no
nothing there.
No man behind the curtain?
So here is my account. There's nothing here. Well, now there's something here.
Does anybody have any questions they want to ask Matt while we watch the console update? Oh, here, let me for the recording.
Have you attempted to use CloudFormation, and do you have any feedback on if you have what your experience has that been versus Terraform?
I looked at CloudFormation very briefly. I didn't spend too much time on it. Was just a little bit easier for me to get up and going, but CloudFormation is the official Amazon way. So it's kind of, what's your preference? Do you want the official way or do you want slightly easier? So it's.
Well, I was actually having a discussion earlier today about Terraform versus CloudFormation, and we've really only used Terraform, but it sounds like, and I used CloudFormation a long, long time ago, but as the deployment gets more and more complex, I think it's a little trickier to manage with the CloudFormation tooling, where the Terraform stuff's nice because it's all kind of software defined as code on the file system. You can check it in, you can revision it, you can manage. I find that easier to manage than kind of through the web GUI or the JSON files that come out of the CloudFormation output. Any other questions? Well, it sounds like you got stuff already running there.
They're up. We'll see.
I'm happy to run the microphone to anybody who wants to ask a question so we can get it on the recording. There's actually folks on the live stream today too. We do have a live stream up.
Let's see if our site is up yet. I have a hunch that Salt is still building. So not yet. On the way.
It's like it's more maybe what's happening behind the scenes.
And look at what's happening. If it lets me in. So when you do pass in a user data script, you can monitor it by looking at this cloud init output. So in this case, we can see that it's still installing Salt in this case. So once this is done, we'll have a website. Oh, we have a question in the back.
So did you start with any scripts to build all this, or did you build this from scratch, and about how long did it take?
I built this from scratch. The Terraform stuff, maybe 2 or 3 hours, and there was lots of research and debugging along the way. And Salt was pretty close too, but that's because I tried to over-engineer the Salt in the process. My original plan was we're going to do multiple sites and multiple types of sites, and it just took way too long to build, so I backed off for the purpose of the demo. But and you can see it's not a whole lot of code. So I mean, I think the instances is the longest file, and there's not that much here. It looks really confusing, but it could be formatted better, but it's not crazy complicated. It's just figuring out the pieces that you need.
How long have you worked with these technologies, and how long did it take you to feel confident and comfortable using them?
So I've been working with Salt a little over 3 years, and I've been comfortable with it fairly early on. We're just constantly expanding what we're doing with it. So initially it was just we're doing a server config, and now we're doing a server config, and then we're automating our backup cycle, and then we're automating code releases, and when we do a code release, we're pulling this out of the load balancer, we're doing a release, we're waiting for it to warm up, we're putting it back in the load balancer, and then we're doing the same thing on this app server. So it can grow as easy or as fast as you want it to. Salt is just really versatile, and that's why we use it. It has the configuration management capabilities, but then it also has the automation capabilities.
Nice.
And we have a website.
I was going to make a quick comment about that. With Salt, I think one of the difficult things for new people to approach Salt is that flexibility. Like Matt said, you can go as easy or as complicated as you want. And I think a lot of people see the complicated first and try to go down that route and just get really frustrated.
So like the pillars, when we first started down this path, we barely used pillars at all. And since then we have expanded to using them and making things more modular. You can entirely hard code all of that into your states themselves, and you don't need to use the pillars. It's basically just, it adds a little bit of complexity, but it's also makes things more modular and manageable down the line. The same thing with grains or map files or.
What are the advantages that Salt has over like a Chef or Puppet or any of the other similar tools?
So from my experience, because I briefly looked at Ansible, I didn't go too far down the road with the others. So I'll do a lot of my comparisons to Ansible. Ansible is really good for the configuration management aspect. It can start services, it can install things, it can do user accounts, it can do that. But then it's not as powerful at the automation. So while it can set up the servers really well, it's not as great for code releases and orchestrating multiple things across multiple servers at the same time. So that's really where Salt's strength comes in to me, is it's much more of a do-it-all solution versus a specialized solution. Well, that is up, and I proved it worked, and the demo guys only semi-smited me. So now we can go back to our slideshow. So yeah, this is kind of what we were saying. Salt really has no limits. There's currently 316 formulas available on GitHub that are community driven. And formulas are basically just pre-written states. So you can clone this down into your Salt repo, you make a pillar file, and you say go. And it'll make a WordPress site, it'll make a Django site, it'll give you a VPN, it'll make you an Elastic server. Anything that you can imagine, there's a good chance somebody has written a formula to do it. I know Colin sitting there has written multiple of them, so if you have questions, you can ask him. And that's pretty much it. So I guess I have some references up there. So that top one is the demo that I just showed you. If anyone wants to go look at that and play with it, then by all means. Other than that, any other questions? I'll be here.
Any questions for Matt? Oh, let's give him James here.
I saw an error in your console output there earlier.
Yeah, it's unhappy about my Jinja, but then it works. And I'm guessing, because I didn't have too much time to go into this, what I'm guessing is that it's trying to pull that value before it syncs up the grains. Because when you pull the EC2 roles from Salt, it pulls them as a list. So I'm obviously trying to pull the first instance in that list. So I think it tries to pull that, it doesn't work, and then it syncs the grains and say, oh wait, it's yours now, and it starts working.
So I guess my question then though is, how do you know if it works or not when you're doing so many things across so many instances? Like, what's the kind of monitoring or reporting back out whether or not it worked or it failed here? How does that work at scale for you guys?
In this case, if the site comes up, some of the others, we take the Salt feedback and we'll email it out, or we'll post a link to it in our Slack room, or there's various options for different returners that you can use.
Yeah, I think another thing you can do is Salt has a requisite system. So instead of declaratively defining you're going to do these things in this order, you can actually specify in the various Salt states, like this depends on or is required in some other state. So you could have an area which is like the thing that grabbed those values, have a check built into it to say unless those values are already existing, kind of stay here until we can move on. So I imagine for this quick demo, it didn't make sense to try and put all that much logic into it, but that would actually be a way you could work around making sure that those errors don't happen and then self-heal, and you're like, why? I don't know why that happened.
Yeah, so in this case, I have, come on, tab. So you can see down here, I require in Nginx, and I require git. So it's not going to try to make this directory and edit the file permissions until that directory already exists, thanks to the git checkout. And then whenever this is updated, it's going to restart the Nginx service. So
Yeah,
things like that are really, really nice for like the orchestration and the automation like we were talking about.
Yeah, don't be tempted. If you're coming from like Puppet, there is a function in the state system to specify an explicit ordering, but don't do it. You'll end up chasing your tail, trying to figure out why certain dependencies aren't working correctly. I think they put that in there to appease certain user groups, but I would not recommend using that like explicit numbering.
We've had bad luck with that one, yeah.
Any other questions for Matt? All right, well, let's give Matt a big round of applause. Thank you so much for joining us here today.